My name is David Bailey. I'm the General Manager for the Mideast Texas Groundwater Conservation District. And hopefully you're here at the right breakout session. This is Understanding Aquifers. And first we have to give their talk is Rachel Shannon. Rachel is with SS Papadopoulos, said that right, and Associates. She is a senior project hydrogeologist, and more information you can find on Rachel is in the bio in your program. So help me welcome Rachel. Stand here or right here, whichever one you want. Here? Mm-hmm.
Yeah, great.
And it's on.
Hi, can everybody hear me? He told me I can stand in front of the podium so y'all can actually see me. I am here to talk to you about the compilation of an aquifer properties data set that we put together for the entire state of Texas. Sorry, I'm not sure how to get the slides started. There we go. Okay, first I wanted to start with some introductions. My name is Rachel Shannon. I'm a hydrogeologist at SS Papadopoulos and Associates. Also on that team are Vivek Bedeker, who is here today, Chris Neville, Dominic Caparicini, Saul Allen, and then we had some Texas locals as well, Rohit Goswami and Carrie Harrington. This project was initiated and led by TWDB, so we work closely with some of those folks, especially in the modeling groups and the data groups, and that would be Darren Hardwick, Heather Dotson, Amy DeLuna, and Jevin Harding. So let me start just by explaining what we did and why. The short answer to that is that we built an aquifer properties data set for the entire state of Texas for use in improving groundwater availability models. So there's been a lot of talk at this conference about using the best available science, and to do that you need the best available data. And by best available I mean most comprehensive and most accurate. One of the core parameters that we need for these models are aquifer parameters. So that would be transmissivity and storativity, and that information is usually found in aquifer tests. So a lot of people do aquifer tests for a lot of reasons. You can find this information in USGS reports, academic reports. You can get reports from contractors, consultants, local governments, and TWDB itself funds some aquifer testing. So there's a lot of information to be had out there if you can find it. The question is where to find it. And I think that that's a topic that's come up quite a bit in this conference. You know, sometimes you know that there's data out there, or you strongly suspect that there is, but you don't necessarily know where to find it. And so the purpose of this project was to gather as much aquifer properties data together as we could and digest it in a way that it's discoverable and searchable and usable for people putting together the GAMs. So where do we get our source documents? Well, first and foremost, it turns out TWDB is a treasure trove of these documents. If you go to their website today, you will find literally thousands of numbered reports, bulletins, historical documents, some of which have aquifer test data in them. But the other major thing that was done is that Heather Dobson and Amy DeLuna, among others at TWDB, put together a vast repository of documents and scanned them all and indexed them by county. So there's something like 130,000 documents in this depository. The other thing we did is sent out an email to stakeholders across the state, just asking them to give us data if it was available. So I think we sent this out to the entire TAG email list, And we also posted it in the newsletter, just asking anyone to send us data that might be useful to this compilation. The map up there shows the counties where we contacted at least one group or agency. The highlights there are the agencies that responded with data. So not everybody had data, not everybody responded, but one of the purposes of this talk is to kind of get this out, to know that we are collecting this information, and if you have it available, we would like to add it. I will give you an email address to send it to at the end of this talk. So great, we have 132,000 documents from TWDB's document repository. We have something like 4,000 downloaded from their website, and we got another 2,400 from our outreach efforts. So that means we have 140,000 documents to look at, which is great. It's a great data source. The trouble is we have 140,000 documents to sort through. So how do we do that? The thing about this document repository is that mostly they were scanned PDFs. They're in a variety of formats, and some of these data go back 80 years, in old reports, and so the scan quality is also variable. I'm just going to give you a couple examples of some of the stuff that we found as we were working through this. I know you can't read this, but here's an example from a summary report, and it has the data very neatly compiled by well ID. It's got transmissivity values. I think it's got associated coordinates. So this is great. This is already summarized, compiled. It's already pretty database friendly. Here's another document, which is also from a summary. And this one, it also has a lot of information. It's not quite as database friendly. So it's got all these graphs, and on each of the graphs, there's a summary of the results of the analysis. So it's still pretty nice. It's got the well ID, transmissivity values. It's all right there, but it's not quite so easy to extract and compile. And then here's an example of an older document. This is from a report that was published, I think, in the 1970s. And you can see it's got some information. It's got transmissivity. It's got well IDs, although the well IDs are not in a standard format. But there's a lot of stuff in this compiled table that is not there, right? We don't know the aquifer. We don't know the date of the test. There's other information we'd like to know that's not just neatly compiled like this, but it is in the text above. So if we open the document, read through it, we actually can find that information. So we have 140,000 documents to deal with. We need like a systematic way of finding the data that we need, extracting it, and compiling it in a way that's to make it available and searchable for people putting together the models. So I'm just going to run through quickly the method that we use to do that. First step is we OCR'd the entire cache of 140,000 documents. We actually just used Adobe Acrobat Pro to do that. And then we compiled them into an Adobe catalog document. And with that document is an associated index file. You can use those index files to search by keywords. So in this example, I just searched for transmissivity. We actually had a long list of possible keywords. I'm going to show you a couple examples. But this is what it looks like. This is what the search results look like. So it'll have the document number, and it'll have a line of text in there where that word is being used. So I just wanted to show you an example of some of the keywords we were looking for. This is a table from a fairly recent pumping test. This was done in 2021 in Hayes County. And this is a summary table from that document. So when we ran our OCR and keyword search, first thing we searched for, I think, is pretty obvious. Pumping test, transmissivity, storativity. We also looked for analysis methods, because we find that in pumping test reports, they will tell you what method they use. So that's kind of a clue to get to those documents. So what is that? Cooper, Jacob, Papadopoulos, Cooper, and Tice. Those were all keywords we searched for. We also looked for some secondary things like observation well. That can mean a lot of things, but if you see it in a document that also has pumping well, okay, maybe that is an aquifer test result. Same with units for the parameters that we were interested in. So in this case, it's gallons per day per foot, which is a transmissivity unit. So in this particular example, it hit for several keywords. So we've now identified a source document, pulled the data out. We start off just putting it in an Excel file, just getting it into electronic form. Repeat many times, and we have a compiled data set. At this point, we pulled it into a relational database, and we just did this with Microsoft Access. So you can see at the top, that's our Aquifer properties table. That's where our transmissivity data is. We also have a separate specific capacity table. I should mention at this point, specific capacity was not really the goal of the project. So if we found it in compiled tables and things that also had transmissivity data, we didn't want to just throw it away. But there's probably more specific capacity data in these documents than we have actually extracted. So it's it was a bonus more than a direct goal. You'll also notice, this is important, every record is linked to its source document. And I'll get into that a little bit more later, but the point is, in any number you get out of this database, you can find the source that it came from and read through the report. The other thing I wanted to talk about in this data set is the well ID. Every record in this data set is keyed to a unique well identifier. So the actual well identifier used in the relational database is kind of an arbitrary string, but it is cross-referenced to a lot of other well identification information. So, of course, the well ID that was used in the original source document. A lot of times we found, especially in some of the older reports, there was sort of a second well name that was used, and that was mostly location descriptions, things like that. So we would keep both of those. But the important thing is, when possible, we also cross-reference this with known well identifiers that the state of Texas already uses, especially the state well number. And once we have a well associated with the state well number, we can then link it into information that we get out of like the groundwater database and the driller's database, like other standard databases. So it makes it a lot more useful. Once we had everything compiled together, the next step is to standardize everything. We wanted every transmissivity record in the database to be using the same units so that we could compare one to another. So we did that on all our numeric parameters, and we also did that on some of the character strings, like county names, right? There's a limited number of counties, so we wanted to make sure that every time one county was used, it was spelled exactly the same. It didn't have spaces or dashes. So that's what all of that standardization is about. I also, before I move on and show you the data, I wanted to talk a little bit about some of the QA that we did on this data set. In the process of doing this, we found a lot of duplicates. And I think the reason for that is some of our documents would quote other documents or would compile data from previous documents. And so you did tend to find the same well test over and over. So there were sort of two types of duplicates in this data set. One is a duplicate within a source document. So the top table there is an example of that. You can see it has the same source document name and the same transmissivity value, but it's got different screen intervals. So that probably means it's one well test that was done on a well that had 3 screens. So we kept all of that. The second type of duplicate was when we saw one document summarizing another document. And the bottom example there just shows you like one case where we found this. The top document is a summary document, and the bottom one was the original well test. And you'll notice it may not be immediately obvious that this is actually a duplicate, right? Because the well IDs are similar but slightly different. The transmissivity looks very different, but that's because it was in different units. Once you do the unit conversion and you standardize the well ID, you can see that this is actually a duplicate value. I just wanted to stick on that point for just a second because I think sometimes this type of duplication can actually be really useful. This is an example where we had a compilation document that had a well test, and it had one transmissivity value associated with that well test. And the 5 or 6 records at the bottom there are from the original well test document. So that was the original report that had all the original measurement data, and it had a series of analyses that it did. So it analyzed that drawdown data using multiple different methods, and they got multiple different transmissivity values. So I think this is interesting to point out, because at some point between that original source document and the compilation summary document, somebody there made a choice. Somebody there looked at that data, analyzed it, and decided that the best representative value was, in this case, 250. But if you look at the original source, there's actually a range. So depending on how you want to use this, I think it's very useful to have both. If you just need like a representative number to, kind of give you an average or characteristic of that aquifer, great, you can use the 250. If you need a range, if you want to do like a maximum minimum case, the original report is actually useful because it helps you bracket those numbers. And also, you can read the original report and you can decide if it's valid, which number in there you want to use, maybe even pull the original data and reanalyze yourself if it's important to do that. So in our data set, we made a point to link every single record back to the source document so that when you are building your model, you can actually find this and review it yourself and make a scientific decision about it. Okay, enough about data compilation and QA. This is the data. Here are our transmissivity values. We have, 4,412 records that cover 182 counties. One of the things, going back to the well IDs, the well identifiers, is in some cases we did not have an exact location for these wells. We would have the county, but we didn't have XY coordinates. So on this map, a dot represents an actual well with an actual XY coordinate, and if a county is filled in, it means we have at least one record in that county. So you can see that there are a few counties in there that are filled in that don't have a specific location, and that goes back to the state well ID. I think the next task in all of this is going to be to get state well IDs assigned to every one of these records. So that's our transmissivity data. This is our hydraulic conductivity. 1,880 records covering 152 counties. Storativity values, 1,269 records covering 116 counties. And specific capacity, 2,569 records covering 171 counties. So this is the current status of the database. Key point, this data set is available now. It is not available for download. You do have to write to TWDB to request it. That's their email address. So please write to them to request this data, or if you have data to share, send it to them. We would love to get this added. Next step, I think the single most useful thing we can do to expand the usability of this data set is to get those state well IDs assigned. So we're working on that. That effort is ongoing, and probably Heather could tell you a little more about that than I could. We want online or live links to the source document. So once this is available online, we're going to want to be able to provide those, click on it, the source document pops up. We hope to do that in the future. And we will just continue to update it as more data come in. All right, so how are we doing for time? Good? Okay, I'm just going to run through one quick example. This is actually not a GAM. This is just like a screening level application. But this came in shortly after we had the data set compiled. My colleague Vivek was approached to do a screening level analysis to explore the possibility of a new production site. Unfortunately, it's a confidential location, so I can't show you the base map, but it is in the Gulf Coast Aquifer system, the Evangeline Aquifer and the Jasper Aquifer. So, sorry I can't show you a map, but imagine the site as the red oval. We plotted that on a map with the transmissivity data. So that was the data that was available near our site. So you zoom in on that site, and you see two sort of clusters of well testing. And they had two distinct sets of transmissivity values associated with them. One of them was like an order of magnitude higher than the other. So you can pull up the source document, and you can look at these numbers, and you can decide, what number is most appropriate to be used in your screening level model. So at that point, we pulled these transmissivity values and ran a quick test. And this is the resulting drawdown map based on that transmissivity data, just an analytic solution. All right, that's all I have. These are email addresses. So again, to request data or to provide data, please write to TWDB. And if you have any questions about the data compilation effort itself, you can write to me at sspa.com. Thanks.
Thanks for the presentation. I'm Michaela with KT Groundwater. So just a clarification, from now onwards, will the Water Development Board be the ones in charge of updating the database and keeping it live?
Yes, yes. So that number, that email address at TWDB, that is who to write to for all inquiries, questions. Yep. Thanks.